Greetings and salutations, Mr. Sutton, bringing you the Pre-Cal Honors 3-7 Extra Practice Number 2 solutions on graphing rational functions. For this problem, we're trying to sketch the graph of this rational function given these key features. So let's go through these and put whatever we can on the graph and then draw from there. So there's no x-intercept to worry about. We do have a y-intercept of -1 though, so we'll put that on there. We have two vertical asymptotes, which is kind of rare, but we have them at 1 and -3. So x equals 1 gets a vertical dashed line. Same thing back here at x equals -3, so we're going to have to figure this out in a minute. There's no hole to worry about, but we do have a horizontal asymptote at y equals 0, so right on the x-axis. Now we need to have a point on each side of each vertical asymptote to be able to graph everything. I've got a point in the middle here, so I know in this center middle part I'm going to be doing a branch, but I need something to the left of this leftmost asymptote and to the right here as well. So I'm going to plug in a couple additional points. I'll do a point at x equals -4, just pick an x value over here. So plugging -4 into the original function, let's see what we get if we do that. So we've got -4 squared is 16. This is -8, so I have 8 minus 3, grand total of 5 in the denominator, so 3/5 if I crunch those numbers. And I'll just put that on the graph now, why not? -4 comma 3/5 right about there. I do need another point on the right side though, so I'm going to pick x equals 2, seems easy enough. So plugging 2 into the original function, we've got 2 squared, which is 4. 2 times 2 is 4, so that's a grand total of 8 minus 3, or 5. So hey, what are the chances? This also comes out to 3/5. So we've got 2 comma 3/5 right there. Now that I've got a point in each vertical piece of the graph, I've got enough to graph my branches. So my first branch is approaching my asymptotes and going through that point that I just drew, like so. Now this middle is kind of tricky. I have to approach the asymptotes, all of them, and go through this point. So it's going to look like one of these, kind of like a U shape like that. And then in the upper right here, approaching asymptotes, going through the point like so. And there's no holes to put on the graph, so we're good. On this problem, we need to find all the key features of this rational function and then sketch the graph. In order to do that, I'm going to need to do a little factoring and reducing here. So looking in my numerator, I see that I can factor a -3 out of everything. That'll leave me with x squared plus 1x minus 12. And let's go a little bit further now. Let's see here. Numbers that multiply to -12 and add up to 1. That would be x minus 3, x plus 4, and we still have that -3 up there. Down below, numbers that multiply to -3 and add up to -2. That would be x plus 1 and x minus 3. X minus 3's conveniently cancel, leaving us with -3 parentheses x plus 4 all over x plus 1. So we'll be using this simplified function for a few things now. So let's start by finding x-intercepts. Those are going to make the simplified numerator 0, because we want to zero out that fraction, but not zero out the denominator as well. So if I set that equal to 0, I see that x equals -4 is going to zero that out, so that's our x-intercept. For y-intercept, I'm going to plug 0 into the original function for all the x's, and everything is getting zeroed out there except for 36 over -3, so that's going to be -12 if I reduce that. Next, for vertical asymptotes, that's going to make the simplified denominator, x plus 1, equals 0. It's going to make the simplified fraction undefined. So x equals -1 is a vertical asymptote. For holes, those are going to be things that make the original function but not the simplified function undefined. So whatever zeroes out this x minus 3 that we canceled out is going to be the x value of the hole. So if we add 3, we have x equals 3 as the x value for that hole. Next, for horizontal asymptotes, I compare the degrees of my numerator and denominator in the original, and I see that we're tied here. We have an x squared versus an x squared. So since it's the same degree, I just use the lead coefficients, -3 over 1, so we take the ratio of those, and then we're going to have y equals -3 as our horizontal asymptote. All right, not sure if we need any additional points, but let's go with what we've got so far, and then we'll adjust if we need to. So x-intercept of -4, that's right there. Y-intercept of -12, well, my grid lines only go down to -8, but if I go a little bit more down there, -12 is down there somewhere, maybe a little bit further. There we go. I think that is a little bit more to scale with what I'm looking for -12. Next up, we need to do the vertical asymptote at x equals -1. So that's going to be right here, and I'll extend that down to this stray point down here. Our hole at x equals 3 we'll worry about after we've got something else graphed here. Horizontal asymptote at -3, y equals -3 right there. And conveniently, it looks like I've got 1 point on each side of my vertical asymptote. So that means I don't need any additional points. I just need to draw the branches and put the hole on at the end. So over here on the left side, I'm going through this point, approaching but not touching the asymptotes. Same kind of deal on the right side, going through this point, approaching the asymptotes without touching them. And we said we had a hole at 3, x equals 3. So here's x equals 3. Here is where the graph is at that point. So let me put a hole right there, and we're all set. For this problem, we need to find the intercepts and asymptotes for this function and then sketch it. There's not much factoring I need to do in the beginning. I could, but it's not going to help me cancel anything else out right away. But I'll be factoring in a sec anyway, because I need to find the zeros of my numerator. So let's start by getting the x-intercepts, which requires us to set the numerator equal to 0 and solve it. So I'm going to have to factor to figure this out. Numbers that multiply to 2 and add up to -3. That would be x minus 1 and x minus 2. And again, I'm setting that equal to 0 and solving to zero out the fraction here. So I have x equals 1 and 2 for my x-intercepts. Next, for the y-intercept, we're plugging 0 in for all the x values in the original function. And if I do that, everything in the numerator is zeroed out except for 2. In the denominator, we just have 0. So that's actually undefined, meaning we have no y-intercept. For the vertical asymptote, we set the denominator equal to 0. If -4x is 0, that means x equals 0 is our vertical asymptote. There's no holes to worry about because no factors got canceled out on this. For horizontal asymptotes, this is a top-heavy function. We have a higher degree in the numerator than denominator, x squared versus x to the first. Since this is top-heavy, there is no horizontal asymptote. There is, however, a slant asymptote, and we can find it by dividing the numerator by the denominator. Since this is not a binomial down here, I can just divide each term individually by -4x. So I'm going to have x squared over -4x minus 3x over -4x plus 2 over -4x. Simplifying here, the x's cancel. We have an x over a -4 or -1/4 x that we could write that as. Let's see here. These negatives are canceling. We have a plus, x is canceling, plus 3/4. And for this last term, we can just completely ignore this because slant asymptotes are talking about long-term end-run behavior, like when your x's are very positive or very negative. As x gets super positive or negative, this denominator is going to get so enormous that the whole fraction is basically going to approach 0. So we don't have to worry about that last term. All right, let's go ahead and graph out what we've got, and we'll see if we need any additional points. So for x-intercepts, we have 1 and 2. So here's 1, here's 2. We'll see how helpful it is having two of them so close together. There's no y-intercept to graph. Vertical asymptotes, we have x equals 0 right here. And for slant asymptotes, we have -1/4 x plus 3/4, which is a bit of a beast to try graphing, but let's do it out anyway. So we've got 3/4 for the y-intercept, so it's right about there. Now, this is a little bit tricky. Our slope is -1/4, so we're going down 1 over 4. Another way of thinking about this, though, is you could think of this as going down 1/4 and over 1. If you're at 3/4 and you go down 3/4, that means you must have gone over 3. So something like this, going through the y-intercept and the point 3, 0, that would get you the line that we're looking for. And it looks like we need a little more information. We don't have anything on the left side of the vertical asymptote. So let's go ahead and plug in an additional point. Let's try x equals -1 plugged into the original function here. Let's see what y value that gives us. So -1 squared is 1. We're doing +3, so that's going to be 4, plus another 2 is 6. All of that over +4 gives us 3/2. So we have the point -1 comma 3/2, which is right about there. Now we've got enough information. So we're going to graph a branch that goes through this point that we just drew and hugs those asymptotes, approaching but not touching. And then we're going to do the same thing on the right side here, go through these points, hug the asymptotes, something like that. And there is one more thing we have to be thinking about, and that's the hole. Only there is no hole on this graph. So actually, we are completely finished with this one. Woohoo!